Thanks, Ed. Wow. So this is a first for me. I can't see any faces, and usually I use faces and the energy from everyone in the room to feel the talk. Um, so very new experience. Thanks a lot for the opportunity, Ed. So yeah, my name is Martin Cronje. I've been in the industry for about 25 years, and having played roles as engineer, architect, and also engineering leader in a number of organizations. So the talk that I'm covering off today is how we turned our most significant production outage into lasting and positive change. Now, I think the content of this talk is very relevant to most people and most organizations, because this is not a talk of Netflix or one of those large organizations and the amazingly swanky stuff that they're doing in those organizations. This is how we in a more common environment dealt with sort of like just production challenges and how we try to improve. The company that I worked with chose to remain anonymous. My role there was as an engineering leader, working closely with the technology leader and the platform and application platform and site reliability teams within that environment. So I assume one or two of those people are have joined up to the call as well, and this is really their work that I'm just sharing with you as a group. So I think without further ado, I read Phoenix Project a number of years ago, and when I started working with this environment, I felt that I needed to read it again because we were living it. I could name the characters in the book sitting on the floor around us, and it was pretty important for me to add. To get the people within the team to start reading that book as well, because we had a lot of similarities. We ended up solving the problems in very different ways, but nonetheless, it was a good point of reference. And this talk isn't really a talk about best practice or textbook or sort of like an ivory towers, idealistic approach to solving these problems. It was really pragmatically, are we trying to solve production issues within our environment? And the overarching principle that we followed here was governing, sort of like trying to achieve cohesive collaborative teams that has end-to-end ownership of their production services. Sort of like kind of build it, run it model. So this talk really covers off how we solve those problems, and not necessarily the topologies, so like the team structures that we set up around that. I think we learned quite a lot on that throughout the journey, but I would say that's almost an entirely different talk by itself, and I felt that it was important to remove that content. So maybe to set some context, the company that I worked with in this space first launched their product around the early 2000s. Throughout the 2000s, they again launched a second major iteration of the product. Now, if you were coding during the 2000s, you probably would have had a computer like this. You probably would have had a gigahertz Pentium 3, maybe a Pentium 4 with a gig of RAM, and surprisingly, only 20 gigs of storage. You would probably have run Windows 2000, Visual Studio 6 using InterDev, and Visual SourceSafe if you were a Microsoft environment. I used a tool called Alere Home Site, which was really awesome. And you would not have had agile or test-driven development, clean code refactoring, or even emergent architecture as concepts floating around in your head. Maybe if you were working in a Smalltalk environment or some of the really cutting-edge Java environments, you would have used some of these practices, but they were very rare back in those days. And it's worth reflecting on the fact that the heart of this product was built during that period of 2000 to 2010. So you would really have built the heart of the product was built around 2000 to 2010. And that was the period where things like TDD and refactoring and collaborative programming and continuous integration and all of that stuff started coming to the fore within the industry. And some of that was adopted into the product, but it was really elective and based on what was right for them at that stage. And you would see this in very many environments where that sort of like heritage in the environment would not have adopted these practices. And that's very common. And I think the thing that's key for you to remember is that all companies have that heritage. It doesn't matter at what point the company was started, that heritage is always present. And that these heritage systems really enabled the companies to become successful. And they are actually still paying the salaries for most of the people working in the environments. And if you're working on swanky new technologies, those projects are probably still funded from the original uh, sort of like old products that you were sort of like running within those environments. You know, we even visited PagerDuty a few years back, and they were talking about how their Ruby stack was sort of like their heritage and how they were dealing with some challenges in their environment. So it's pretty prevalent everywhere. So I guess a question for you, as you know, the attendees here today, is to take a moment and reflect on what is the heritage within your environment. So what is the stack? And you're welcome to share that on the chat, and you know, some of the people can sort of like reminisce about the different technologies that you're running, and from that perspective, you know, you'll get a minute to think about it, and I'll continue the talk again. Well, I guess, as I said, you know, heritage is pretty prevalent in many of the environments. So continuing our story, around the 2000s, this product was moved to the cloud. Some of the underlying technologies were modernized, and the company also started building an innovative new user experience. That new user experience ended up disrupting the market and allowed the company to start expanding globally, which was really cool. And roughly what the new user experience looked like was we would have had this original sort of like core monolithic code base that was sort of like built in the original 2000s, and that was expanded to have a new API layer, and then this new product that was built on top of that, using sort of like the micros UI, sort of like very common approach that we would see today, micro UIs with back-end to front-end services. And this is a very common way to extend the lifetime of a legacy system. You know, I did a similar thing with a mainframe with Natural Database COBOL back in 2001. So very common approach, and were usually very successful to help companies expand. And we did see that in the environment. What we had within the environment was the sort of like heritage product with virtual servers, manual deployments, manual provisioning, and infrastructure provisioning. And on the other side, we had this new product, which cloud native, continuous deployment with some automated infrastructure provisioning. And one of the things that we really saw within these environments is that part of the reason we had some automated infrastructure provisioning and not all was that they still ran a bit of a older traditional operations team where there was a lot of toil, and that's one of the big themes throughout this talk, is that there's transitioning from a old school operations almost IT team where, you know, they manage licenses in the morning and, you know, configured servers in the afternoon, through to a more automated DevOps type of environment. Some of the other things to highlight out of the environment was we had pretty mature agile delivery, but very low test automation, very disruptive incidents, high reliance on long tenured engineers, and then obviously this traditional ops team with high toil. Oopsie. Now, the environment also had about 40 major incidents per month. So these are Sev 1s, Sev 0s, and Sev 2s. And that chewed up anything from 20 to 40% of the engineers, sort of like day in, day out capacity. And one of the problems that we saw here was there was no agreed definition of what good looks like for the product. So a customer would do something within the product, they would be unhappy, and then suddenly they would you know, log a call, and that call would hit the engineering teams and be massively disruptive to the teams. So there was no real gauge to say, actually, the customer says it's slow, but actually the system is still performing well. So it was very reactive. One of the other things that we saw was that there was minimal monitoring within the environment. So the engineers didn't really know that something's going wrong, or wasn't able to analyze the product. So one of the first things we did was buy a bunch of monitors so that people could pull their sort of like monitoring, and that helped really well. But the perfect storm was brewing. We had hands in the code. We had a lot of hands in the code. We had dated code. The company was scaling. And on top of that, we had a new system that was using this old legacy code in a different way. So something for you to reflect on for a minute is, do you have any of these perfect storms brewing in your environment?